Ah, kids, you should, just from playing around with stuff, you should already know that anytime SO is bigger than F, okay, that you will get a real image. So drawing ray diagrams for real image is pretty easy. I want to show you how to draw ray diagrams for virtual images for a concave mirror. It's also pretty easy as long as you just follow the steps. So we're going to start by drawing a principal axis. So everybody draw a principal axis. Use a straight edge. Okay. Then we're going to draw our concave mirror that we're going to have to kind of draw it in the center. And I'll explain why. But there is our concave mirror. Okay. And then using a ruler, what do we want to do for our focal? Let's make our focal 10 centimeters. So where it hits, I'm going to go, let's not go 10. That's a little bit too big. We'll go, how about 5 centimeters? 5, okay. So there's my focal point at 5, and then that means my center of curvature would be at 10. So there's F, and there would be C. Okay. And then I want to draw my object, has to be in here someplace. So there is my object. Okay. Everybody good? All right. I don't love my curved mirror here, but that's okay. So really, when we're drawing it, we're going to pretend it's going to this point anyway. So like I'll just sketch in just a line straight up and down there. We're just going to go to that line anyway. Okay, even though it is a curved mirror. But when we're drawing it, we're just going to go to that line. All right, so let's do our rays. Okay, so the first ray is our parallel ray. So it comes in parallel, and then it reflects and goes through the focal point. Okay, and then we have to do that one in reverse. Now, that one in reverse might seem a little confusing, and I'll actually use a different color just to make it a little bit easier to see. But I just have to go focal point here, mirror. So, and then it goes up straight. So, does everybody see how I'm lining it up? Focal point with the tip of the object. Okay, and then it's going to bounce off straight. Hopefully I can draw it straight. Okay. And then I just have to do one of my others. So if I want to do my center ray, I can do my center ray. If I want to do the one that's hitting the middle, I can do the one that's hitting the middle. It's up to you. So I'll just use the center ray because that's the one that's going to go straight. So it would look something like this. Okay. And then that light ray would actually bounce back that way too. Now you might look and you might go, wait a second, I have this light ray, and this light ray. Well look, even if I keep going, these light rays are never going to meet over here. And you're right, they're not going to meet over there. Because remember, when SO is less than F, you get a virtual image, which means virtual means the light rays don't actually go there. Your brain just thinks the light is going there. So that means I have to extend the reflected part backwards. And we did this when we were doing the plane mirror stuff. So it's, hey, this goes here and then this way, so I have to extend this backwards. Okay, it's always extending the reflected part backwards. So dot, 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 dot. And I'm dotting it because, okay, that the light is not actually going back there. If I extend the red one backwards, it's going to look something like this. Okay, and then if I extend that center ray backwards, hopefully it will meet where the other two met. If I do it right. There you go. And it looks like I did a pretty decent job. And then again, the whole point is to locate the image, so we better draw the image in. So the image is going to be right about here. So there would be my virtual image. Now, when you're doing your packet stuff, you then would measure SO, you would measure F, you would solve for SI. In this case, SI is going to be negative because it's a virtual image. And then you would do the same thing, solving for the magnification. But hopefully that should make sense as far as actually drawing your ray diagram. All right. Bye, kids.